In modern astronomy, there is a new technique that has come out in the last handful of years called adaptive optics. And since Hubble, we're used to pictures being beautiful if they were taken by a space-based telescope. But with adaptive optics, we can begin to get some good images from land-based telescopes. Why is that an important thing? Well, it's important for a couple reasons. One, more astronomers can actually get their hands on the data. More astronomers can point light into the sky where they want to point it. There's only one Hubble. There will only be one James Webb. And with adaptive optics, you can have multiple telescopes by multiple astronomers on any one moment that are getting good images from space. Adaptive optics allows us to correct for wave distortion in the atmosphere. The best example of this is a mirage. If you have ever, let me get my little eraser here. Sorry, bad sound effects. If you have ever been driving down a road in the summertime and up above ahead of you, you see a wavy heat pattern coming up off the road, that is a mirage. Now, if an astronomer is on the ground and they're trying to look at a star out in space, there is heat that comes from the Earth that is going to cause the air to wiggle or vibrate. Adaptive optics can be used to fix that, and it uses computer-controlled deformable mirrors. With adaptive optics, we have ground-based images that unlike anything we've ever had before. Here's a couple pictures of Neptune. Without it, Neptune was just a blue blob. With adaptive optics, you can actually see the storms and you can see the rotating bands of the planet Neptune. This is a globular cluster. Globular cluster is one type of cluster of galaxies, of stars, and with it, it's much clearer, and without, it's very blurry. So this is a big deal in the history of astronomy. Up next is a very short video that does a much better job of explaining adaptive optics than I ever could.